Okay, let's talk about the sequence of excitation. It's really important that we get the timing of the heart right. We need to have the blood enter into the atrium, drain into the ventricle, go back into the lungs, return via the left atrium, enter into the left ventricle, and be ejected into the aorta. That needs to happen in a very precise timing. So the electrical activity that we talked about of the heart, starting at the sinoatrial node, being transmitted through the internodal pathway, hitting the AV node, delayed for approximately 0.1 seconds, then transmitting the electrical activity to the bundle of His, then the left and right bundle branches, and then finally to the Purkinje fibers. Then the heart contracts. Remember, electrical activity encounters the membrane, and then there is a latent period before contraction occurs. So let's just draw a quick diagram of the heart once again. We're going to keep it really simple on this ways. We have our SA node right here, AV node, bundle of His, our bundle branches, Purkinje fibers. And then from there, let's go below and look at what an ECG might look like from here. So we're going to use this as each one of the traces that we talk about are going to be a time. So let's start with one right here. The SA node depolarizes, begins to depolarize. Right there. So, and we're going to look at that as just like that. It's starting, but it's starting to transmit the electrical activity down the internodal fibers there, which is then going to encounter our AV node. And from there, once it encounters there, we're going to start seeing our atria start to depolarize and contract. So once that happens, this is part 2, we see our ECG starting to come up here. That's our P wave. That's atrial depolarization. The AV node is now depolarized, and it's starting to send the electrical activity down the bundle of His and into the left and right bundle branches. And we can say this is right here, atrial excitation. Right here we begin it, and we finish right here. And at this point, once the AV node is triggered and begins to depolarize and send the electrical activity down the bundle of His and into the left and right bundle branches, the depolarization comes through here, and then it looks a bit like, it looks like this. Sorry about that. We have our P wave, Q, and then we get the beginning of our R wave right here. And then as the depolarization travels through here, then we get contraction of the ventricles after our latent period. And our ECG now looks like this at the end. P wave, Q, R, S, like that. Begin. So P, Q, R, S. Those are that. Okay, and then lastly, this is ventricular. Okay, and then from here, lastly, we need to relax things. So once the depolarization has traveled through, the muscles have contract, we need to repolarize the system. And that's what ventricular relaxation is. So this is known as systole here, this is dystole. So systole is the contraction, the higher number on your blood pressure. Distally is the relaxation, the lower number. So our heart is basically reset. There's no electrical activity in here. And as the repolarization happens, we see an additional wave on the ECG. We have a T wave, and this is ventricular repolarization. This is the T wave. This is the repolarization of the ventricles. The atria are repolarized in there too, but the QRST wave is so large, there's so much electrical activity in it that it gets washed out into it. So knowing what normal is, a normal PQRST wave, can help us understand when there's any fluctuations or anything abnormal in the electrical activity of the heart.